out of the clean channel was to be able to get this really breathy, spongy feel out of it that's very reminiscent of amplifiers that were built in the 40s and 50s. It's got a kind of a creamy feel to it. When you hit a note, the dynamics just have this really magical bounce to them. The problem with a lot of amplifiers is they're so stiff when you play them, and by having a Class A output stage with the 6v6s, you can drive the amp with your fingertips from going from clean into that Class A power amp distortion and then back into the clean, and it's this really seamless, just beautiful transition between the two states that just gives you the goosebumps when you listen to it. And on the lead side, by having the high gain preamp coupled with that spongy output stage with that really super sweet top end, it's like having the most delicious milkshake. I mean, this is really great tone. We wanted the amplifier to actually be called something with a V because the military call out for a 6v6 is a 6 Victor 6. And we thought about it, Victor's not as feminine and not as pretty a sounding name. And then I thought, you know what, Venus is the goddess of love. And when you play this amplifier, you fall in love. So Venus seemed like a really natural name for this amplifier because it's a love thing. The Venus 6 output transformer is really a magical transformer. This transformer was originally designed by Tommy Reichenbach. We use this transformer in several of our Rivera models. It has very, very close coupled primary and secondary windings. They're interleaved many times, which means that the primary and secondary are wound. You wind the primary, then you wind the secondary, then you wind the primary, then you wind the secondary, and by coupling the windings very close, you actually eliminate some of the bugaboos inside the transformer, and you have a much better transfer between the input of the transformer, the primary, and the output transformer, the secondary. You have a smoother frequency response, you have less parasites, you have many, many less problems. It's an expensive process because it takes a lot of labor to stop, tie windings off, start again, tie windings off. It's a start-stop process, and most transformer companies, especially some of our competition, in order to cut costs, do not employ that kind of technique in the winding. We also are very careful of the core material that we use. We use a very high quality core material, and so by doing that, as well as a large core, we have an extended frequency response range. That transformer is virtually flat from 30 to 30 kilohertz, which is a very wide range for a transformer. And what that means is that the harmonics that you hear when you play, there is no distortion of the harmonics, or I should say bad distortion of the harmonics, at the higher frequencies because there's such a linear transfer between primary and secondary and because of the massive core. We gave the Venus 6 a bias adjustment, a very small range that allows us to use and optimize the amplifier for a wider range of output tubes. For instance, in a production lot of output tubes, even though we match them, there is a range of plate current and other specifications of the tubes that will vary over a certain window. So by having a small bias adjustment in the amplifier, this allows the amplifier to be optimized no matter what tubes that we put in. So for musicians out in the field, if they get a matched pair of output tubes that is of one value or of another value, there's enough range of adjustment of idle current in the amplifier to be able to set it for the proper idle current setting. In most Class A amplifiers, which use fixed resistors in the cathodes, they are tuned to one particular value of output tube. If you have a higher gain tube or a lesser gain tube, one tube draws more plate current, it will not be biased optimally because that resistor was chosen for a particular parameter of a particular set of output tubes. So as far as I know, we're the only Class A amplifier manufacturer that allows you to optimize that amp's idle current in the Class A mode in a small range. We have chosen high quality components for all of our amplifiers based on the philosophy as pay now or pay later. If you pay now, you have amplifiers that are reliable and give a long service life. If you pay later, you're going to lose your reputation, you're going to have lots of amplifiers blow up in the field, and you're going to have a lot of pissed off customers. So I'd much rather pay now than pay later. I've got my personal name on this amplifier, and 20 or 30 years from now, God willing I'm still alive, I want to be able to walk into a club and see that amplifier working and have the musician tell me, oh yeah man, I've had this thing for 35 years and it's never let me down. That's what I want to hear. So I build my amplifiers according to those principles. So for example, our filter capacitors. We use 105 centigrade, long life, low ESR filter capacitors. We chose these capacitors, and many of them are custom made for us because it's not an off-the-shelf item. We chose these capacitors because they have the longest possible life at an elevated temperature in an amplifier. Tube amplifiers generally run warmer than solid-state amplifiers. You've got two big glowing tubes heating up the chassis. And as most manufacturers use commercial-grade components, and unfortunately most of them are now using Chinese-made commercial-grade components, they're rated for 65 degrees. That is a big difference, 65 centigrade to 105 centigrade. And as such, they're going to have a very short life. One of the biggest manufacturers of amplifiers, even that they claim they're made here in America, uses these 65 degree centigrade capacitors because they're cheap. So we've gone out of our way to use very expensive filter capacitors. Now our coupling capacitors are made by WEMA in Germany. WEMA is audiophile quality coupling capacitors. These are metallized polyester, these are polycarbonate. These capacitors are used in the most expensive esoteric hi-fi. Our power switches are made by Marquardt in Germany. They're the most reliable power switches that we can buy. We do not use Asian-made power switches. We don't want them to fail. They're very reliable parts. We use metal barrel jacks. They're more expensive than plastic jacks, but imagine an amplifier with a jack that's plastic, the barrel. That means that the ground contact on the plug that you're inserting has just a tiny little leaf that's kind of just touching the barrel of the jack instead of the entire jack itself. So from a ground contact standpoint, a metal barrel jack has far better grounding. So we use that throughout. Second thing is, how many times have you dropped an amplifier or it's fallen on its face or it's had a plug in it and something has brushed up against the plug? I mean, it happens all the time to musicians. Plastic barrel jacks crack, they break. I mean, one of the largest manufacturers who I happen to used to work for has had these plastic jacks in their amplifiers for years, and if you talk to warranty service centers, they'll tell you that they replace them all the time because they break. When, British amp manufacturers use a typical British style from Cliff or Rian of these plastic jacks that have the plastic nuts. Again, the plug itself is only being contacted on two little surface points, and if anything happens where the amplifier is bumped or dropped or anything else when the plug is still inserted, that jack will break. So great, you got this amplifier that you just paid $2,000 for, and it uses cheap plastic jacks. No thank you.